Solving differential equations. A differential equation is merely an equation with a differential. For example, if I look at these two equations, they are both first order differential equations as they contain dy by dx or its equivalent, but nothing else. A second order would contain d squared y by dx squared, however that would only be covered at further maths. There are two things that you need to know how to do to solve a differential equation. One is finding a general solution, and the second is finding a solution. Now if we look at the finding a general solution, here is an example. I have 1 over 2x dy by dx equals 2y plus 3. My first step is to separate my variables. All this means is getting every value of y on one side and every value of x on the other. If I rearrange, I get this. I am now going to integrate both sides with respect to x. The reason I have done that is if you look at the left hand side, I get dx and divide by dx which cancel to leave me with this. I've now got an integral with respect to y on one side and an integral with respect to x on the other. If I perform these integrals, I get a half log 2y plus 3 equals x squared plus a. My last step is going to be to rearrange this into the form y equals. If I multiply through by 2 and then take exponentials of both sides, let's just briefly look at the left hand side. The e and the log will cancel. If I look at the right hand side, I have e 2x squared plus 2a. Our laws of indices state that we can then separate these into this. I have e log 2y plus 3 equals e 2x squared times e 2a. Now my e 2a is just going to be a constant, so I can rewrite that in any form I want. I've used b. Let's evaluate that. I now get 2y plus 3 equals b times e 2x squared. If I subtract 3 and divide by 2, I have a general solution. It's called a general solution because it has that unknown constant still in it. When we are finding a solution, I can't have that constant, so therefore I must be given a set of conditions that would allow me to find it. So here's an example. If I x times dy by dx equals y plus 3, I am told, however, that y equals 3 when x equals 2. My first step, as before, is to separate my variables. Then I integrate with respect to x and cancel my values of dx. I now have the integral of 1 over y plus 3 with respect to y equals 1 over x with respect to x. Integrate both sides, leaving with log y plus 3 equals log x plus a. I am now going to plug in my values of y equals 3 and x equals 2, use my laws of logarithms to find a being log 3. I'm going to take it and put it back into my equation, leaving me with log y plus 3 equals log x plus log 3. I can combine this right hand side using the laws of logarithms to give me log y plus 3 equals log 3x. Take exponentials of both sides and then rearrange. I have y equals 3 equals 3x. Then that can be rearranged to y equals 3x minus